Welcome, everyone. I have really been looking forward to this deep dive because the source material we have on the table today is just so incredibly unconventional.
Oh, absolutely. It's definitely not your standard reading material.
No, not at all. We are unpacking a highly provocative, very visually driven blog post out of Japan. It was published in March 2026, and this is not a standard peer-reviewed academic paper.
Right. Far from it.
Yeah, it's part of this sprawling, passionate, and honestly somewhat rebellious ongoing series. The author titled it Mr. Einstein's Slacking.
Which is quite the title.
It really is. And the specific entry we are digging into is Draft 112, Simultaneity and Light Ray Reflection in Spacetime Diagrams. But what makes this particular source stand out so much is the medium the author actually uses to make their argument.
Yeah, they use Blender.
Exactly. They're using a 3D modeling and rendering software, Blender, to fundamentally critique the last 100 years of theoretical physics. It's
Yeah.
just such a fascinating approach to untangling some of the most complex ideas in science.
It really is. And, the choice of a 3D rendering engine like Blender is actually the perfect vehicle for the author's core thesis.
How so?
Well, our mission in this deep dive is to unpack exactly how this author uses that software to argue that modern physicists are completely misunderstanding space-time. The entire argument really hinges on the physical reality of what the author calls the camera eye.
The camera eye.
Yeah. We are going to explore the critical, often overlooked difference between abstract mathematical models, so the kind that exist purely as concepts, and actual physical observation in the real world.
Because there's a huge gap there.
A massive gap. And by the time we trace the author's logic through these 3D models, the distinction between a mathematical map and the physical territory, well, it might just flip your understanding of reality entirely.
I love that.
Yeah.
So let's jump straight into how the author builds this universe inside Blender. They create a very distinct visual setup. They refer to this modified visualization as the interferometer skirt hem.
Which sounds bizarre, but makes sense when you see it.
Yeah, the skirt hem. So in a typical 3D software environment, you have your standard Cartesian coordinates, right? You've got an x-axis and a y-axis for the flat ground plane, and then a z-axis for height.
Right, the basic 3D grid.
But the author modifies this by completely swapping out that vertical z-axis. Instead of representing physical height or depth, that vertical line now represents time.
Denoted as t.
Exactly. So up and down is now past and future.
And that vertical time axis is really the foundation of space-time diagrams. But the author grounds this abstraction in a very specific physical mental image.
Okay, walk us through that.
So we are asked to look at the flat plane where time is exactly 0, just the flat ground. On this plane, imagine a perfect circle with a radius of 10 units.
Okay, got it. A circle on the ground.
Now, the author then places exactly 3,600 individual atoms along the boundary of this circle. And it's crucial to note, these aren't just mathematical points. We are meant to envision 3,600 physical atoms sitting completely stationary within Maxwell's electromagnetic field.
So it's a very dense ring of physical matter.
Exactly. This dense ring of atoms gives us a high-resolution, 360-degree physical boundary to work with. It is our baseline of reality at the present moment. Time 0.
And having those 3,600 individual atoms just sitting there in a circle at time 0, that is where the author starts pushing against our standard cognitive habits.
Right, because it's hard to visualize.
It is. They argue that when humans try to process this setup, we actually rely on 3 completely distinct ways of conceptualizing the image, and they claim only one of them actually reflects reality.
And breaking down those 3 distinct ways of seeing is essentially the skeleton key to the author's entire critique.
So let's break them down.
Sure. The first method is the realistic image. This requires you to literally hold the picture of those thousands of multiple physical atoms sitting in electromagnetic space right there in your mind.
Which is a lot to juggle.
It's concrete, it accounts for physical matter, but it is incredibly taxing on human cognition. Because our brains struggle to hold that much physical detail, we inevitably slip into the second method, which the author calls the imaginative image.
All right, we take a mental shortcut.
Exactly. We step out of physics and into Euclidean geometry. We stop picturing 3,600 atoms, and instead we just visualize 2 or 3 points. We imagine simple, pristine line segments connecting them, focusing really only on the endpoints and midpoints.
Yeah, which leads directly into the third method, the symbolic image. And this is where the author believes theoretical physics has essentially trapped itself.
Trapped itself completely.
Yeah, because we leap entirely away from the physical atoms and dive into algebraic equations. We split the visualization into that 2D Cartesian plane of x and y, plus the vertical time axis, or we abstract it even further into complex mathematical space.
The physical atoms are just gone.
Right, they're gone, replaced entirely by pure symbols, formulas, and geometry.
And when you adopt that purely symbolic perspective in the Blender software, tracing the path of light over time creates a very specific 3D shape.
The hourglass shape.
Right. So if light travels outward from a central event over time, moving outward on the x and y axes, while moving upward on the 2-axis, it creates a cone shape opening toward the top of your screen.
And that is your future light cone.
Exactly. Conversely, light arriving at that center point from events in the past forms a cone opening downward.
The past light cone.
Right. And viewed from the side in the software viewport, the tips of these two cones touch right at the present moment times 0.
So it creates a shape that looks exactly like an hourglass, which ties back to the author's phrase, the skirt hem.
Yeah, the skirt hem.
But the author looks at this geometric hourglass shape and throws a massive red flag.
They really do. The author insists that this 3D model, as it is traditionally understood, is a fake image.
A fake image?
Yeah. It is a construct born entirely of Euclidean geometry and mathematical abstraction. It represents a reality that no physical observer in the universe could ever actually experience.
Because it's missing something.
Right, because the visualization lacks a crucial physical component. It lacks a camera eye.
Okay, let's unpack this. Because the author's transition into the mechanics of 3D software rendering here is honestly brilliant. They contrast two different ways a program like Blender can render a 3D scene on your 2D monitor.
Parallel projection and perspective projection.
Exactly.
So parallel projection is the visual equivalent of the mathematical abstract. Imagine viewing that hourglass shape of the light cones from a mathematical infinity.
Like incredibly far away.
Right, say I equals -1000. In this rendering mode, there are no vanishing points and no depth distortion at all.
So things don't get smaller the further away they are.
Exactly. If the base of the future light cone and the base of the past light cone share the same radius, they will render on your screen at the exact same size.
Regardless of where they sit on the time axis.
Right. It is a theoretical, omniscient view. The flaw, according to the author, is that there is no actual camera in a parallel projection.
Right.
There are no physical light rays traveling through a medium and striking a physical lens. This viewing angle happens entirely in the abstract space of the human head.
It's the ultimate God view, totally untethered from physical constraints. But the universe doesn't operate in a God view. To map actual reality, the author turns to perspective projection.
Which is how we actually see.
Exactly. Think about how a physical camera operates in the real world, particularly one with a telephoto lens. In perspective projection, you must define a specific, concrete coordinate for the camera eye.
Which represents the physical observer.
Right, because physical reality dictates that objects closer to a lens appear larger, the rendering changes entirely here. The future light cone, which is extending forward along the axis toward the camera, will physically appear larger to the observer than the past light cone, which is receding.
What's fascinating here is the profound realization the author draws from this software mechanic. Both of these projections in Blender, the parallel God view and the perspective camera view, are ultimately just happening in Cartesian mathematical space.
They're just drawing geometry.
Right. They are drawing geometry. They are not mapping Maxwell's actual electromagnetic space. To transition from a mathematical map to a physical territory, you cannot just draw shapes in a grid. You must account for the physical behavior of light.
Specifically, information delay.
Yes. Information delay.
And information delay is really the engine driving this entire critique.
It is. Information delay represents the actual physical time it takes for a light ray to leave one atom, travel across physical space, and strike the specific atom of the observer.
The camera eye.
Exactly. If your model of the universe does not calculate the specific travel time for every single light ray based on its exact physical distance to the observer's location, you are not modeling reality. You are just playing with geometry.
And the author does not mince words when pointing out how long the scientific community has been playing with that geometry.
Oh, they go hard.
They really do. They launch into a scathing, highly personalized critique of theoretical physicists over the last century. I mean, the author outright calls them a bunch of fools.
Yeah, that's a direct quote.
They are described as math-obsessed and big-headed. It is a fiery, relentless takedown of the academic establishment. And we should make it clear, you listening, we are just reporting on the source material here. We are not taking sides in this academic dispute.
Of course. Our job is just to convey the ideas. But the rhetoric is undeniably hostile. Yet, looking objectively at the root of that hostility reveals a serious philosophical grievance.
What's the core of their anger?
The author is arguing that for a century, physicists have been calculating the universe inside that Cartesian mathematical space. They've been operating in the parallel projection God view without treating the observer as a physical entity governed by physical laws.
Right. The observer is just a math point to them.
Exactly. The observer, which the author frequently refers to as an intelligence officer, isn't just a coordinate point. It is a physical entity that must physically receive radio waves or light rays to have any knowledge that an event even occurred.
So the author suggests that physicists successfully figured out how to take 2D mathematical equations and mentally extend them into 3D mathematical spaces, but they just stopped there.
They stopped at the geometry.
Right. Their ultimate crime was failing to map the actual physical spatial verification of those events. They looked at the math and simply assumed the math was the physical reality.
And the author diagnoses this as a severe case of narrowed thinking.
And an egocentric attitude. They claim it has effectively sealed away obvious, observable truths from the scientific community.
It is the ultimate critique of confusing the map for the territory. The theoretical physics community constructed a mathematically flawless map of space-time, but they forgot that in the physical universe, looking at a map takes time.
Right.
They failed to account for the time it takes for the light bouncing off the map to actually travel through space and reach their own retinas.
Okay, here's where it gets really interesting. The author moves beyond the insults and lays out a defining thought experiment to prove exactly how information delay shatters the mathematical consensus.
The interferometer experiment.
Yes. They set up a scenario using an interferometer. Now, for the sake of visualizing the motion, we can just picture this interferometer as a train moving along the track at 60% the speed of light.
So that is a velocity of 0.6 c.
Exactly. And this train is traveling along the x-axis, moving forward toward a coordinate of positive 100.
Okay, so to test the physics of this moving train, the author places two specific observers in the universe to monitor it. Observer A is stationed far behind the train,
Standing at a coordinate of negative 1,000 on the x-axis.
right, and observer B is stationed far ahead of the train, standing at a coordinate of positive 1,000 on the x-axis.
So we have a train moving fast between two distant observers. Inside this fast-moving train is the interferometer device, which is designed to shoot beams of light in different directions simultaneously.
So one beam is fired straight forward,
Parallel to the tracks, in the exact direction the train is moving. We will call this the x-axis arm.
and the second beam.
The second beam is fired perpendicular to the tracks, bouncing sideways back and forth. We will call this the y-axis arm.
Okay, so first, we have to establish the pure, abstract mathematical reality of this setup. The God view without a camera.
What happens on paper?
Exactly.
Yeah.
Inside that moving train, the light racing forward along the x-axis arm is essentially chasing the front wall of the device.
Because the wall is speeding away from it.
Right, actively speeding away at 60% the speed of light. Because it has to chase the moving wall, the mathematical reality dictates that the reflection on the x-axis arm happens later than the reflection on the perpendicular y-axis arm.
Because the axis arm is just bouncing sideways, it doesn't have a headwind, so to speak.
Exactly. That is the objective sequence of events on paper. The x-axis reflection happens later.
But the author points out that this objective mathematical sequence is completely irrelevant to what the observers actually experience in physical space. And this is entirely because of information delay.
Let's look at observer A first.
Right, the person standing way behind the train at negative 1,000. For observer A, the light bouncing sideways on the axis arm is physically closer to them than the light bouncing off the front wall of the x-axis arm.
Because the front wall is further away down the track.
Exactly. Because the sideways light has a shorter physical distance to travel through space, the light ray reporting that the y-axis reflection happened wins the race to observer A's camera eye.
So the report of the sideways bounce arrives first.
Arrives first.
Now look at the exact same event from the perspective of observer B.
Standing far ahead of the train at positive 1,000.
Right. The entire train is rushing directly toward them. From observer B's physical location, the front wall of the x-axis arm is constantly closer to them than the sideways y-axis arm.
Because it's the front of the train.
Exactly. Because the front of the train is physically closer, the light ray carrying the report from the x-axis reflection has a shorter distance to travel.
So that light ray wins the race to observer B's eye.
Yep. The report of the forward bounce arrives first for observer B, even though mathematically we know it happened later.
It's wild. The chronological order of events completely flips depending entirely on where the physical camera eye is located in the universe.
It fundamentally breaks the idea of universal simultaneity.
It really does. And the author provides another incredibly clear analogy using a standard train to hammer this point home.
The 20-unit train.
Yes. Imagine a physical train that is 20 units long. It passes the dead center of the tracks at 60% the speed of light. The physical light generated by this event takes exactly 1,000 seconds to travel from the center point down the tracks to reach an observer standing at positive 1,000.
Okay, so if a bulb flashes in the exact center of that moving train carriage, the mathematical model says the light will hit the back wall of the train first.
Why?
Because the back wall is moving forward to meet the expanding light. It is driving into the light ray, shortening the distance. So mathematically, the back wall is illuminated before the front wall.
But the observer, standing way down the tracks at positive 1,000, does not see the back wall illuminate first.
No, they don't.
They receive the light reflecting off the front wall of the train first. Simply because the front of the train is physically closer to their camera eye, the light reflecting off it has a shorter track to run.
So the physical observable reality completely contradicts the underlying mathematical reality of the event.
And connecting this back to the author's broader philosophy, this is why the concept of the intelligence officer is so vital to them.
Right. An intelligence officer in the field doesn't just look at a piece of paper and log the exact time a courier dropped a report on their desk as the time the event occurred.
That would be terrible intelligence.
Exactly. To uncover the actual truth of the battlefield, the officer must calculate the exact time the event was emitted and the exact location it was emitted from. They have to do the grueling work of subtracting the physical travel time of the courier to reconstruct reality.
So the author's ultimate indictment of theoretical physics is that by ignoring information delay, the brightest minds of the century have been confusing the arrival time of the courier with the actual timeline of the universe.
That's a great way to put it.
To solve this massive discrepancy, the author introduces a new framework. They call it the unit circle model.
The unit circle model.
Yeah. They argue that we have to entirely discard the habit of visualizing a physical, spherical screen out in mathematical space where events just objectively happen.
Because that's the God view again. The unit circle model demands a total paradigm shift.
So how does it work?
Instead of a God view spatial map, we must view the universe as a complex, localized space that explicitly maps the history of light rays reaching one specific point.
Reaching the camera eye.
Yes. To model reality accurately under this framework, you have to account for the specific direction of incoming light and calculate the exact time delay of every single photon that eventually strikes your physical camera eye. You are no longer mapping where things are. You are mapping the delayed historical reports of where things were.
So only by doing that are you plotting actual physical reality rather than just generating geometry in a 3D software program.
Exactly.
It is a staggering amount of invisible architecture to consider just to understand what we're actually looking at.
It is. And that raises a crucial point for you, the listener. While this deep dive has been heavily anchored in the mechanics of theoretical physics, interferometer setups, and 3D rendering engines, the underlying lesson is really a masterclass in critical thinking.
I totally agree.
The author is essentially urging you to rigorously question the maps you rely on every day. When you look at a data set, a complex business model, or a narrative in a news report, are you just looking at a mathematical abstraction?
A fake image.
Right. Or are you actively accounting for the information delay, the actual time, the inherent bias, and the physical distance it takes for that reality to be packaged and delivered to your specific perspective?
You have to ask yourself if you are confusing a pristine theoretical God view map with the messy, delayed physical territory of your own camera eye.
It applies to so much more than just physics.
It really does.
Yeah.
The maps we use are truly only as reliable as our understanding of how they were constructed and who constructed them. And I want to leave you with one final provocative thought to mull over as you go about the rest of your day.
Let's hear it.
If everything you see, everything you hear, and everything you physically experience is essentially a delayed historical report arriving from the past, traveling at varying speeds based on its distance from your body,
Right.
then is your entire concept of the present moment just an illusion synthesized by your brain?
Oh, wow.
And if so, how much of your daily reality is actually just a ghost of the past? Something to think about. Thank you for joining us on this deep dive into the source material. Keep questioning those maps, and we will catch you next time.